Alright, in this video, we are going to look at adding and subtracting rational expressions. So when we're adding fractions or rational expressions, the only way that we can do that is if the denominators are the same. And so the first thing that we're going to have to do in these problems is if they do not have the same denominator, the two rational expressions, is we've got to find what we call the least common denominator, right? And we typically just put LCD for least common denominator. Now, what you want to do with these rational expressions to find the least common denominator is to factor each denominator as much as possible. Right, so here our two denominators are x plus 3 and x minus 6. Those two will not factor any further than what they already are. And so what we're going to do now, once you have the denominators factored, we're going to go through each denominator and write down each factor that we see. Now, if a factor occurs more than one time, we don't necessarily have to write it down exactly how many times it occurs. We just need to make sure that we write each factor down the most amount of times it occurs in a single denominator. Right, so in this first example, in the first denominator, our factor is x plus 3. So we need to write that down as part of our least common denominator. And then move to the second rational expression. The only factor in its denominator is x minus 6. All right, so we have written down each factor that we see in each denominator, and so our least common denominator is x plus 3 times x minus 6. Right, so what we need to do now is rewrite each of these rational expressions so its denominator is the LCD. Right, so if we look at this first rational expression, look at its denominator, again, it has the factor x plus 3, and so you have to ask yourself, what do we need to multiply to x plus 3 to make it x plus 3 times x minus 6? So it's obvious we need to multiply by x minus 6. Now, in order to not change the value of that rational expression, the only thing that we can multiply by is 1. And so since we need to multiply the denominator by x minus 6, we're going to multiply the numerator by the same exact thing. Because if you take any number that's not 0 divided by itself, it's just 1. So if we multiply the first rational expression by x minus 6 over x minus 6, we're just multiplying by 1. And so that's what we're going to do here. And so the way I'm going to write this down, so we have our numerator, go ahead and write that down over, and I'm going to put the denominator x plus 3 in parentheses, and we're going to multiply by x minus 6 over x minus 6. And so we need to multiply the numerator by x minus 6 and the denominator. All right, if you multiply the same non-zero number to both the numerator and denominator, you're not going to change this value. And you can see now the denominator is x plus 3 times x minus 6, which is the LCD. And so then we move to the second rational expression, and we ask ourselves, well, what do we need to multiply to its denominator to make that denominator the least common denominator? So this denominator is x minus 6, so we need to multiply it by the x plus 3 here so that its denominator will be the least common denominator. And so again, whatever we multiply to the denominator, we need to multiply the exact same thing to the numerator, because then what we've done is just really multiplied by 1. Right, because x plus 3 divided by x plus 3 is just 1. All right, so now, and again, when we're doing this and rewriting so that they have the least common denominators or denominator, we don't need to multiply what we have in the denominators out, right? Just leave it in factored form, x plus 3 times x minus 6. Now that they have the same denominators, when you to add two rational expressions at the same denominator, you keep the denominator and you add their numerators. Right, and so what I'm going to do is go ahead and write down one rational expression, and so the denominator is x plus 3 times x minus 6, or, if you put the x minus 6 first and then the x plus 3 second, it's the same, right? Multiplication is commutative, so order does not matter. So if we look here, again, what we can do in that first numerator, I'm going to go ahead and distribute that 2 there. So that first numerator, 2 times x is 2x, and then we got minus, and 2 times 6 is 12, and then plus, and then the second numerator, I'm going to go ahead and distribute the 5. That's 5 times x is 5x, and then plus 5 times 3 is 15. All right. And so now all that's left to do in the numerator is combine the like terms. All right, so our denominator is still x plus 3. Still x plus 3 times x minus 6. And combine the like terms in the numerator. The 2x plus 5x will give us 7x. And then negative 12 plus 15 is positive 3. Now, the only other thing we might have to do, if you can, if the numerator will factor, and then, and if once you factor the numerator, if the numerator and denominator have any factors in common, then you can simplify. 7x plus 3, we can't factor that any farther from what we have. And the numerator and denominator here have no common factors, so there's our final answer. All right, so that process, factor the denominator so that you can find the least common denominator, rewrite each rational expression so that they have the least common denominator, and once they have the same denominator, keep the denominator, and again, if it's addition, add the numerators together. If it was subtraction, we would subtract. All right, so let's look at this example. So we'll look at a problem here where we are subtracting. So again, the first step here, we're going to need to factor each denominator. All right, so I'm going to go to this first rational expression here. So I'm going to go ahead and write down the numerator, x. Now, x squared minus 4 is the difference of squares, so it's going to factor x plus 2 times x minus 2. Then we have minus, so then the second rational expression, we'll go ahead and write down the numerator 3. Now, x squared minus 3x plus 2, if you factor this, you'll get x minus 1 times x minus 2. All right. And so we have both denominators factored completely. And so now we need to write down the least, determine what the least common denominator is. And so, again, I'm going to go through each denominator, and I'm going to write down each factor that we see. All right, so in this first denominator, I see x plus 2. The next factor in that denominator is x minus 2. Then I move to my next denominator. The next factor I see is x minus 1. And then last, we have x minus 2. Now, I've already written down x minus 2, right? So I do not need to write it a second time, right? The only time that, you would write down a factor twice here for for a least common denominator is if that factor occurred 2 times in one single denominator, right, in the same denominator, right? So we only need to write down that x minus 2 once, right? So now we need to rewrite each of these so that they both have the LCD as its denominator. So looking at this first denominator here, right, the only factor it's missing in the LCD is x minus 1. So we're going to multiply this first rational expression by x minus 1 over x minus 1. And so what we're going to get, so need to multiply the numerator by x minus 1, and we're also going to multiply the denominator by x minus 1. Because essentially we're just multiplying the rational expression by 1. And then we've got minus, and we'll go ahead and write down the second rational expression. Right, so in this second denominator, the factor that it needs in order to have the least common denominator is x plus 2. Right, so we're going to multiply the numerator and denominator of the second rational expression by x plus 2. All right, so now both denominators have the same. Both denominators are the same. They're both that least common denominator. Now you notice the order of the factors are different in each, but they both have the same exact 3 factors. And again, with multiplication, it's commutative, so order does not matter. And so what I'm going to do now, before I distribute in the x in this first numerator, before I distribute that and before I distribute the 3, I'm going to go ahead and write this down as one single rational expression, right? So I'm going to keep the denominator, and the order that you put these 3 factors in does not matter, right? So I'm going to have to go to the next slide. So we've got, in no particular order, the denominator, we got x plus 2, x minus 2, and x minus 1. Right, so then we're going to take the first numerator, which is x times x minus 1. And then we've got minus, and then the second numerator, 3 times x plus 2. And the reason I'm waiting to distribute what we have in the numerators is because it was subtraction, right? We need to make sure that we distribute that minus sign throughout the really what was the second numerator, right? And that's important with when we're doing subtraction. So now I'm going to distribute. So in the first part, x times x is going to be x squared, and then minus x times 1 is simply x. So we're going to have x squared minus x. And now distribute negative 3. So negative 3 times x is negative 3x. And then negative 3 times 2 is negative 6. So minus 3x minus 6. And again, that's all over x plus 2 times x minus 2 times x minus 1. So we combine like terms in the numerator. And I should be putting equal signs here. So combine the like terms in the numerator. So we're going to have x squared. Negative x minus 3x is negative 4x. And then we got minus 6. And that's over our denominator. And again, you don't have to multiply out the denominator. Just write it in factored form. Now the numerator won't factor, so we are done.